Hello students, in this video we will discuss if value of one definite integration is given, then how to find the value of other definite integration in terms of given value of definite integration. We know in definite integration mostly we don't integrate function actually. What we do? We use the properties of definite integration and also the properties of function. Now in this section we will see if one value is given, then how to find the value of definite integration in terms of given value without actually integrating the function. So let's start with the questions. The first question is, if value of this definite integration is alpha, we have integration of e power t upon 1 plus t. For the limits 0 to 1, this value is alpha, then we have to find the value of this definite integration in terms of alpha. The first thing to be observed is we check the nature of functions in both the integrals. Here we have exponential function in numerator. So here also we have exponential function in numerator. Here in denominator we have a linear function. Here also we have linear function. We can say the structure of both of these functions is same. Basically we can say they are from the same family. The DNA of these two functions is same. So let's see how we can make use of this. I will try to write this function like this. Here we have exponential e power t, here we have e power minus t. So on later stages we will substitute for minus t is equal to something. Now here we have 1 plus t and here t minus b minus 1. So what I can do, I can arrange this and rewrite like this. Since here we have 1, okay, so what I can do, I can take minus sign common, and then I have 1 plus b minus t. Here we have dt. Now let's club this b minus t. Now we have here 1 plus some linear function. Here we have 1 plus t. So what I'm going to do, I will substitute for b minus t. So let's substitute for b minus t. This is equal to say y. What will be change in the limits when we have b minus 1, t is equal to b minus 1. So we have at that time y is equal to 1, and when t is equal to b, we have y is equal to 0. So here I am changing the limits from 1 to 0. Now what is e power minus t? Here minus t is y minus b. So I will put here y minus b. Okay. Also what is dt? I have minus dt is equal to dy. So I will replace dt by minus dy upon I have 1 plus y. Okay, so now this is equal to, okay, now I have one minus sign here, one minus sign here. I will get one more minus sign by reversing this limit. So actually I have minus sign. Also from this I can take out e power minus b outside integration. So I have this integration e power y multiplied by dy upon 1 plus y. Okay, now you can match this integration with this. Here we have e power t upon 1 plus t. Here we have e power y upon 1 plus y. Both these integrations, in fact both these functions for integration are same. The only change is that of dummy variable. Here dummy variable is t and here dummy variable is y. So I can write this as alpha. So actually I have minus alpha multiplied by e power minus b. So I got this value of definite integration in terms of this definite integration, the value of which is alpha. So here actually we are not integrating the function. Okay, we are making use of properties of definite integration, and also we have one substitution, smart substitution. Okay, now let's test second question from this category. The question is, if the value of this definite integration is alpha, then find the value of this definite integration in terms of alpha. Okay, now what is the first step? We will compare the functions. Here we have sine t upon 1 plus t. Here we have sine t by 2. We will consider this as, here we have a sine of some linear function which is t. Here also we have sine of linear function, just t is replaced by t by 2. Here we have 1 plus t. We have 1 plus linear. In fact, we have linear function in denominator. So also here we have linear function in denominator. So to match the DNA of functions, what we do, here we have t, then we have 1 plus t. So here in numerator and denominator we have t. So similarly, we must have here t by 2 in denominator, because here we have t by 2 in numerator. So what is my first step? I will take out 2 common from the denominator. So this integration is like this. I am taking 2 common from the denominator. So denominator will be 2 pi plus 1 minus t by 2. Okay, what next? I have here 1 plus t. Now I have here 1, but in place of t by 2, I have actually 2 pi minus t by 2. So what I am going to do, I will club this 2 terms, 2 pi and minus t by 2. So this will look like this. We have 1 plus 2 pi minus t by 2. Okay, next is the function here and here, or expression here and here, must match, because here we have t. So I can use substitution. 2 pi minus t by 2 is equal to y. So let's substitute for 2 pi minus t by 2 is equal to y. We know that in the definite integration is actually game of substitution most of the times. Okay, so here we have minus dt upon 2 is equal to dy. So dt is actually minus 2 dy, and there will be change in limits also when t is equal to 4 pi minus 2. So if I put here, I will have 2 pi minus 2 pi minus 1 is equal to y. That means y is equal to 1, and when t is equal to 4 pi, I have 2 pi minus 2 pi is equal to y. That means y is equal to 0. Okay, so in this I will change limits and also function. I have 1 to 0. Okay, now t by 2 is 2 pi minus y. So I have here sine of 2 pi minus y, and the value of dt is minus 2 dy. Okay, in denominator we have 1 plus y. Now one can say here we have y, here we have 2 pi minus y. Still this expression is not matching. But here we can make use of trigonometry. What is sine 2 pi minus y? It is actually minus sine y. So now we have actually 3 minus sign. One from change in the limits, one from this, and one from this minus 2y. So actually I have minus of 1 upon 2 integration from 0 to 1 sine of y upon 1 plus y multiply by 2 dy. Here also 2 gets cancelled out. Okay, now you can match this integration with this. Here we have dummy variable t and here we have dummy variable y, otherwise function is same. So this is actually minus alpha. Here we have minus sign and this value is alpha. So answer is minus alpha. So again in this question we got this value in terms of given integration value without integrating. The use of smart substitution and properties of definite integration, that is a change in limits, and then we have inversion of limits, etc. Okay, the question is if the value of this integral is alpha, then find the value of this integral in terms of alpha. Okay, so first of all we will compare the functions. Here we have exponential in the numerator, so we can write this like this: e power minus x cube multiplied by x square dx upon, also here we have 1 plus x. Now here we have 2 minus x cube. So we can write this denominator as 1 plus 1 minus x cube. Okay, now tell me what we can substitute for in this integration. Now here we have only exponential function. Here we have a exponential function, that too with power 3 of x. We have here x cube, here we have only x. Also here we have x square. And then we have here 1 plus linear. Here we have 1 plus cubic. So the substitution will be 1 minus x cube is equal to t. There and then I will have 1 plus t in denominator, like here we have linear function. So let's change the limits here. When x is 0, the value of t is 1, and when x is 1, the value of t is 0. Then what is e power minus x cube? From this we have minus x cube is equal to t minus 1. So I have here e power t minus 1. By differentiating this I get minus 3x square dx is equal to dt. So what is x square dx? It is actually minus dt upon 3. So I have here dt and minus 1 upon 3 outside integration sign, and in denominator I have 1 plus t. Okay, now I have actually here two minus signs. One is here and one is from change of limits. So I have 1 upon 3. This integration limits are from 0 to 1, and also from this I can take out e power minus 1 outside. So I have here e power minus 1. So inside integration I have function e power t upon 1 plus t. Now you can see this function is same as this function. The value of this integration is given. This is alpha. So I have this is equal to alpha upon 3e. This e power minus 1. So e will go into denominator. I have alpha upon 3. Well, let's do now one last question from this category. Here is the question. The question is if value of this integral of cos x upon x plus 2 square for the limits 0 to pi is equal to alpha, then prove that the value of this integral sin 2x upon x plus 1 for the limit 0 to pi by 2 is equal to this 1 upon 2 plus 1 upon pi plus 2 minus alpha. The first step is we will match the function, we will compare the functions. Here we have cos x in numerator, here we have a sin 2x, functions are not same. Here we have x plus 2 square of linear, in fact perfect square of linear. Here we have only linear function. Earlier three equations, here functions are not matching. So if we compare with what we can do in this question, how we can start the question. Now tell me one thing, in integration, how you get sine function in place of cos x. Also here we have in denominator square of linear, here we have only power 1 of linear. So what you do here to get function of this type? In place of sine we get cos, and in place of x plus 1 power 1 we get something like square of linear. Clearly we will integrate this using by parts. Okay, so let's integrate this using by parts. We have 0 to pi by 2 sin 2x upon x plus 1. Okay, what will be the first function to which we will differentiate? Straight away the first function will be 1 upon this, because if I differentiate this function I will get 1 upon square of linear. So we have now 1 upon x plus 1 multiplied by integration of sin 2x, that is minus cos 2x upon 2. The limits of integration are 0 to pi by 2, okay, minus integration of function, derivative of 1 upon x plus 1 is minus 1 upon x plus 1 whole square, multiply by integration of sin 2x again. So we have here minus cos 2x upon 2. So we are using integration by parts. In this we will put the value of limits. So if I put here pi by 2, I have here cos pi, and cos pi is minus 1. So I have actually 1 upon 2 times pi by 2 plus 1 minus, if I put here 0, cos 0 is 1, but here we have minus sign again. So actually I will have plus sign here, and this is 1 upon 2, because here we have 0 plus 1, that is 1. Okay. We are getting this half plus 1 upon pi plus 2. So we are getting this terms here. So we are going in right direction. Okay. Next, here we have minus minus minus. So we have 3 minus sign. The limits are 0 to pi by 2. Okay. And then we have here cos 2x upon 2 times x plus 1 square. Okay, what next? How we can get this value in terms of alpha? In fact, we have to prove that this is alpha, so we will get this result. Now here we have x plus 1 and here we have x plus 2. So what change I can make here? Also here we have a 2x and here we have x. So straight away the substitution is 2x is equal to y here. So I will have limits from 0 to pi. In place of cos 2x, now I have cos y. What is dx? Dx is 1 upon 2y. What is in denominator? In denominator I have here 2 and y by 2 plus 1 whole square. Okay, now I can write this as minus of integration for limit 0 to pi cos y upon y plus 2 whole square. This 2 from here gets cancelled out and I get y plus 2 square in denominator, and this value is alpha. So I am getting my result that this value is equal to this one. So in this question we have one new thing, that is we are actually starting our question using integration by parts. We are first integrating the function and then we are having substitution to match this function with this function. And it is quite easy because here we have x plus 1, here we have x plus 2, and here we have 2x, here we have x. So clearly the substitution is 2x is equal to y. But the key concept of this question is integration using by parts. And what will be the first function and the second function? Clearly from this I want 1 upon linear square. That means I have to differentiate this function. So for first function and second function we are not using any hit and trial method. We have clear idea